Right now, you are sitting still. Or so it seems. But the truth is far more dramatic. You are hurtling through the vast, dark emptiness of space. You are moving faster than any bullet ever fired, faster than any rocket ever launched. Right at this very moment, you are traveling at 1.3 million miles per hour. This is not science fiction. This is your reality. It is the speed of our entire solar system, our sun, our Earth, all of us, carried on an unimaginable journey through the cosmos. We feel nothing of this motion. We wake up, we drink our coffee, we live our lives, completely unaware of the tremendous velocity we possess. This incredible speed is not our own. We are passengers, adrift in a current far grander than any ocean. Our planet is caught in the gravitational pull of our sun. Our sun is caught in the immense gravitational embrace of our home galaxy, the Milky Way. It is a river of stars, gas, dust. We are but one tiny vessel swept along in its flow. The journey is silent. It is constant. It has been happening for every moment of your life and for every moment of human history. The ground beneath our feet feels solid and stable, a fixed point in the universe. But it is an illusion, a beautiful deception. We are, and have always been, cosmic travelers on an epic voyage. So, a question arises. Where are we going so fast? And what is this immense structure that carries us with such purpose? We look up at the night sky and see a faint, cloudy band of light. Our story begins long ago, in the deep, silent darkness of the early universe. Nearly 14 billion years have passed since the Big Bang. In the aftermath of that singular moment, the cosmos was a very different place. It was a hot, dense soup of particles and energy. There were no stars, there were no planets, and there were no galaxies. There was only a vast, expanding fog of hydrogen and helium gas, but it was not perfectly uniform. Tiny, almost imperceptible fluctuations in density existed within this primordial mist. These were the seeds of everything that was to come, planted in the first moments of time. Over millions of years, gravity began its slow, patient work. It is the great sculptor of the cosmos. The denser regions of gas began to pull in more and more material from their surroundings. They grew larger, more massive. These were the proto-galactic clouds, the ancestors of the galaxies we see today. Imagine countless wisps of cosmic smoke swirling and coalescing in the dark. Our own Milky Way began as one such collection of gas and mysterious dark matter. It was a formless entity, slowly but surely gathering the raw materials needed to build a city of stars. It was a promise of light in a universe that was still almost entirely dark. The first stars ignited within these collapsing clouds. They were giants, blue, brilliant, and living fast, violent lives. Much larger than our own sun, they burned through their fuel in only a few million years. When they died, they exploded in cataclysmic events called supernovae. These explosions were not just endings. They were also beginnings. They scattered heavy elements, forged in the hearts of these first stars, out into the surrounding gas. Carbon, oxygen, iron, the very elements needed for planets and for life, were seeded into the galaxy. Our galaxy was enriching itself, preparing the ground for future generations of stars, and eventually, for us. So what is this structure we call home? From the outside, our galaxy would look like a vast, spinning pinwheel of light. It is what astronomers call a barred spiral galaxy. At its heart is a dense, elongated bar of older, yellowish stars. This bar acts like a cosmic traffic director, funneling gas and dust from the outer regions toward the galactic center. It is a place of intense activity, a bright, bustling hub from which the rest of the galaxy extends. This central bulge is ancient, containing some of the first stars to ever form in the Milky Way. It is the Old City, the historic core of our stellar metropolis. Extending from this central bar are the magnificent spiral arms. These are not solid structures. They are more like cosmic traffic jams. They are density waves, ripples of higher gravity that sweep through the galactic disk. As gas clouds pass through these arms, they are compressed. This compression triggers furious bursts of star formation. This is why the arms are so bright. They are illuminated by the brilliant blue light of hot young stars. Our own sun resides in a smaller, partial arm called the Orion Spur, nestled between two larger arms, the Sagittarius arm, the Perseus arm. We live in a relatively quiet, suburban neighborhood of our galaxy. The main disk of the Milky Way, containing the spiral arms, is immense. It is about 100,000 light-years across. To put that in perspective, if our solar system were the size of a quarter, the Milky Way would be the size of North America. It is a flat, sprawling city of light, but it is also incredibly thin. While it is 100,000 light-years in diameter, the disk is only about 1,000 light-years thick. It is thinner, proportionally, than a vinyl record. All of this, the disk, the arms, and the central bar, are surrounded by a vast spherical halo of scattered old stars and ancient star clusters. And how many neighbors do we have in this city? The estimates are staggering. The Milky Way contains somewhere between 100 billion and 400 billion stars. For every single person who has ever lived on Earth, there are dozens of stars in our galaxy alone. And we are learning that many of these stars, perhaps most of them, have planets of their own. This opens up a profound possibility. With billions of stars and potentially trillions of planets, it seems almost inevitable that we are not alone. Our galaxy could be teeming with worlds, some like our own, some fantastically different, all part of this single, sprawling cosmic family. Our personal sense of time is defined by the Earth. A day is one rotation, a year is one orbit around the Sun. But our Sun has its own orbit, on a scale that dwarfs our human conceptions of time. Just as the Earth is gravitationally bound to the Sun is bound to the supermassive black hole at the center of the Milky Way. Our entire solar system is on a grand circular tour of the galaxy. This journey is long. It takes our Sun approximately 230 million years to complete a single orbit. This vast expanse of time is known as one galactic year. Think about what that means. The last time our solar system was in this same position in the galaxy, dinosaurs roamed the Earth. The continents were just beginning to drift into their current positions. The first mammals were small, nocturnal creatures, hiding from the great reptiles. Since that time, the dinosaurs have risen and fallen. The age of mammals has dawned. And in the last tiny fraction of this single galactic year, all of human civilization has emerged. Our recorded history is but a few seconds on this great cosmic clock. We have been alive for only a flicker of a galactic moment. Our journey is not a gentle one. As we orbit, we move up and down through the plane of the galaxy, like a horse on a carousel. We pass through regions of varying density. Sometimes we travel through the dense, bright spiral arms, where nearby supernovae could pose a risk. At other times, we are in the sparser regions between the arms, like we are now. Some scientists have even speculated that these passages through different galactic environments could have influenced life on Earth, perhaps triggering mass extinctions or periods of evolutionary change. Our fate is tied not just to our Sun, but to the very geography of our galaxy. The center of our orbit is a place of profound mystery and power. At the very heart of the Milky Way, some 26,000 light-years away, lies Sagittarius A. It is a supermassive black hole, a point of infinite density with a gravitational pull so strong that nothing, not even light, can escape. It has a mass more than 4 million times that of our Sun. Every star in the galaxy, including our own, is held in orbit by the combined gravity of all the other stars and, most importantly, by this unseen monster lurking in the core. It is the silent, invisible anchor around which our entire galaxy revolves. Well, yeah. When we look at our galaxy, we see stars, we see gas, we see dust, we see the visible matter. For a long time, we thought that was the whole story. But there was a problem. The galaxy is spinning too fast. The stars on the outer edges are moving with such velocity that they should fly off into intergalactic space. The gravity from all the visible matter we can see, even the hundreds of billions of stars, is not nearly enough to hold the galaxy together. It's like watching a merry-go-round spinning so fast that the children on the edge should be flung off, yet they remain firmly in place. There must be something else, something massive, yet completely invisible. Scientists call this missing ingredient dark matter. It does not emit light. It does not reflect light. It does not interact with forces we are familiar with, except for one: gravity. It is a cosmic ghost, a silent, unseen presence that outweighs all the visible matter in the universe by a factor of more than 5 to 1. We don't know what it is, but we know it is there. Its gravitational influence is the glue that holds our galaxy, and all galaxies, together. Without it, the beautiful spiral structures we see would have torn themselves apart long ago. The Milky Way's vast, spherical halo extends far beyond the visible disk of stars, and is thought to be composed primarily of this mysterious dark matter. It forms an invisible scaffolding, a gravitational framework upon which our galaxy was built. The gas and stars in the visible Milky Way are like the lights on a Christmas tree. The dark matter is the tree itself, unseen, providing the essential structure. This realization has fundamentally changed our understanding of the cosmos. About 85% of all matter in the universe is of a form we cannot see and do not yet understand. This mystery is one of the biggest challenges in modern physics. Our journey through the cosmos is not a solitary one. The Milky Way is part of a small cluster of galaxies called the Local Group, and we are on a collision course. Our nearest large galactic neighbor, the Andromeda Galaxy, is hurtling toward us at about 250,000 miles per hour. It is a cosmic spectacle, a gravitational dance that began billions of years ago. Right now, Andromeda is 2.5 million light-years away. But even at that immense distance, it is the most distant object you can see with the naked eye, a faint, fuzzy patch of light in the night sky. This is not a collision in the way we think of it on Earth. It will not be a crash of fire and destruction. Instead, it will be a slow, graceful merger. Because the distances between individual stars are so vast, direct collisions between stars will be exceedingly rare. It would be like two swarms of bees flying through each other. The swarms will merge, but very few individual bees will actually touch. Instead, the two galaxies will pass through one another, their shapes distorted by powerful gravitational tides. Stars will be flung out into long streams. The elegant spiral structures of both galaxies will be torn apart. This process will take hundreds of millions of years. After the first pass, the two galaxies will separate, only to be pulled back together again by their mutual gravity. They will dance and swirl, merging and reshaping each other over the eons. Eventually, after a long and complex gravitational tango, they will settle into a single, much larger galaxy. The gas from both galaxies will collide and collapse, triggering a spectacular burst of star formation, a galactic starburst that will light up the newly merged entity. Our night sky, for any observers who might exist then, will be a blaze of glory. The final result of this merger will be a new, giant elliptical galaxy. The beautiful spiral arms will be gone, replaced by a massive amorphous ball of older stars. Scientists have already given this future galaxy a name: Milky Way. And what of our Sun and Earth? It is likely our solar system will survive. We will probably be thrown into a new, much larger orbit within this new galaxy. The collision is destined to happen in about 4.5 billion years. By that time, our Sun will be nearing the end of its life, swelling into a red giant. The fate of our galaxy is intertwined with the fate of our star, a future written in the laws of gravity. Well, that's the long view. We have journeyed across immense scales of space and time. From the dizzying speed of our solar system to the birth of our galaxy in the aftermath of the Big Bang. We have seen its structure, a city of stars 100,000 light-years across. We have contemplated the Great Galactic Year, a 230 million-year orbit that dwarfs human history. We have confronted the profound mystery of dark matter, the unseen scaffolding of the cosmos. And we have looked ahead to a distant future, to a cosmic collision that will reshape our galactic home, It is a story of unimaginable grandeur, enough to make one feel small and insignificant. But the final truth of this story is not one of separation. It is one of profound connection. Every piece of our world, every rock, every ocean, every living thing is intimately tied to the life and death of the stars in this galaxy. The first stars, those ancient giants, forged the heavy elements in their nuclear furnaces. When they exploded, they scattered these elements like seeds into the cosmos. Carbon, nitrogen, oxygen, iron, all the building blocks of planets, all the building blocks of life. Subsequent generations of stars, including our sun, formed from these enriched clouds of gas and dust. This means that the story of the galaxy is also our own personal origin story. The iron in your blood, which carries oxygen through your veins, was created in the heart of an exploding star billions of years ago. The calcium in your bones, which gives you structure and strength, was forged in the same cosmic crucible. The carbon that forms the basis of your DNA, the very blueprint of your existence, was once part of a distant, long-dead star. We are not just living in the Milky Way. The Milky Way is living in us. We are, in the most literal sense, stardust. So the next time you look up at the night sky at that faint, milky band of light stretching across the heavens, remember what you are seeing. You are not just looking at a collection of distant suns. You are looking at your own ancestral home. You are looking at the source of the very atoms that make up your body. You are a child of the cosmos, a way for the universe to know itself. Every atom within you began its journey in a star, and has been traveling through this galaxy for billions of years, just to be here now as you. Well, simply incredible.